And good afternoon, everybody. I'm happy to be here again on stage. So I'm going to talk to you about security and privacy and what this means in the blockchain industry. So a little bit about Least Authority and why I and the company care about security and privacy. We like to help others make technology more secure and build secure technology ourselves. We do this through security consulting, which is mostly security audits, but also security by design and talking to people about how they build their projects. We do this through community participation by partnering with other companies in the community that care about security and privacy. And we also do this by supporting research and encouraging new developments within the space. We do have a product called the Simple Secure Storage Service, and this is for individuals to do secure storage of their data in a cloud environment. We also concentrate on empowering users by encouraging privacy by design and the idea of people holding control over their own data. So we get this question a lot about what the name Least Authority means, and so I think it's worth taking a second to explain that Least Authority, company name, is named after something called the Principle of Least Authority or the Principle of Least Privilege. This is the idea that components of a system should only have enough authority necessary to perform the function that they need to perform, and nothing more. The belief is that by limiting the authority within pieces of our systems, we can also limit the damage caused by security breaches of those components or pieces of the system. So this is about security. So why does security matter to all of us here today? Well, security is something that's very important for this field to keep in mind as we move forward. We have grand visions of what our products can do for the world. We're creating solutions to difficult problems. We're creating solutions that can also bring new business opportunities to existing markets. And we are hoping to revolutionize industries around the world. Our systems need to be reliable in order to achieve these goals. We need to consider the security of our blockchain technology and care about how the data that we store can be accessed or modified. So here's some examples of some hacks that have been very popular around the world on what you might call existing popular technology, centralized systems. You can see that we've learned a lot of hard lessons from these hacks, and they continue to happen. Blockchain technology is the next generation of technology, and we can help to avoid this. So I want to tell you a little bit about different ways to think about data within our systems. One is data integrity. This is basically not allowing modification to our data by unauthorized parties. This helps with trust. Although trust might mean something different to different people, it is a just basic idea that the data that we have in our systems has not been modified in ways that we don't want it to be modified. Unaltered data is the core to some of the institutions and our businesses. An example of this is the identity information that we store about people within our countries, our societies, our systems. This data should only be altered by authorized parties. It should not be altered without our approval. Another example is supply chain data. We want supply chain data to not be altered by other parties unless we approve of them doing the alterations to that data or the modifications. And of course, it's not possible for us to trust every party in our societies, in our businesses, in our lives. And the immutability of data on the blockchain, on public blockchains, or even permissioned blockchains, this immutability feature of the technology is key. As far as data confidentiality, we want to sometimes restrict access to the data that we hold, and this results in privacy. And this is both privacy for people as individuals and also for organizations. Privacy is important to how our society functions. For an example, certain personal information that we choose not to share with people, or we want to make sure that we share it under our control. In terms of business, this is corporate transactions that you may not want your competitors to see that are occurring about your business partnerships, or perhaps trade secrets. You want to have the ability to reveal this information when appropriate, but perhaps not be out there in public for all the time. So security is about risk management. There is no such thing as a 100% secure system. Our systems are always at risk for being breached. So those are the things that we need to think about when we are thinking about security of our systems. We need to identify these risks. What is the probability of this happening to our system? What is the impact when it does happen? And who is the responsible party to take care of this? And then we can decide on each of these risks whether or not we want to accept them. We would like to transfer that risk to another party. We would like to reduce the risk or avoid the risk altogether by maybe removing something from our systems. And one way to identify these risks within our systems is to do threat modeling, to look at what our threats are. What are the attackers? Who are the attackers? What would they like to achieve by breaching the security of our systems? So these are some common vulnerabilities within this blockchain technology. Number one is endpoint security. Or actually, I should say these are not in order of importance. These are just order of nothing. But endpoint security. As we decentralize our technologies and we push data out to the endpoints in our systems, we need to further secure these endpoints. We need to be considerate of if we're asking users to maintain that data, the control of their own data, how are they doing it? Are they securing their devices? And in what ways are they securing their devices? And it must be mentioned that at this point in time, the endpoint security options are pretty difficult for most end users, and they're a bit impractical for us to expect for everybody to already know how to manage these things for themselves. For example, also private key management. If we expect users to hold their private keys, if we expect corporations to hold the private keys, then we need to make sure that they understand what the security implications are for doing that. And so we as a community need to work together on how to make this easier for people to make the right choice about security. Another one is smart contracts. There was a great presentation about formal verification and how that is one solution to help with the smart contract security. Reentrancy is a particular problem that happens with smart contracts. The ability to implement a loop inside a contract, and this is especially damaging if contracts also grant excess authority in their functions. So we see this a lot when we're doing our smart contract audits with our company, that we look for these types of problems in smart contracts. And another big issue for us is scalability. What might seem like a small, harmless bug or problem in a test net could end up being a way to exploit the system when it's put out to mainnet, and perhaps when real money, or when it's used in production is involved. Another thing to keep in mind is our untested code. A lot of what we're creating is new, experimental. It might be untested both in our systems as our projects are building them, but also perhaps untested when it comes to the actual usage by people in real life. And then last is standards and regulations. Right now, this is new technology, new space. We need to develop standards for security and regulations around security. These are opportunities to hack our technology right now, but they're also opportunities for improvement. So one thing that we do is security audits. Security audits are a review of code, also a review of designs, specifications, and then the implemented code, review of protocols also. And the point of these kinds of reviews are to get are to look for the vulnerabilities before the attackers find them, to find the opportunities to exploit the system and to resolve them before the system could be hacked by somebody else. This not only improves the quality of the systems, but it also engages more stakeholders within the conversation. In some cases, security audits are really useful for just business stakeholders. In other cases, security audits are also fundamental to getting an open source community to gather around improving the technology that they're working on. So about the security audit process. The processes that we usually follow is that we go through a discovery and planning phase. This is a very strategic phase, and it's also a lot of looking at what the project's goals are. We try to figure out what the technology is hoping to do, what it is trying to implement. And that's also how we plan the project, and we look at what the threat model of that particular project or system is. And then we might actually start the investigation. And this is where we look through the code and we look through the documentation and try to find how we could attack this, how we could exploit the system for our own advantage. And then from that, we would identify issues, overall comments, overall thoughts on what the project could do better in terms of security, and sometimes actual identified issues that need to be resolved. And so this produces what's called an initial audit report, basically outlining what these issues are, what these overall design considerations could be that could improve the security of the system. And then that is handed over to the team, or the client, or whoever's working on building that system. And it gives them an opportunity to do mitigation and remediation, which is also suggested when the issues are identified. And in that phase of mitigation and remediation, it's really up to the individual projects or businesses to determine whether or not that they think that that risk is worth addressing, or if it's something they want to reduce, accept, transfer, or avoid. And then once those changes have been made, then we would come back and look again at the changes that have been made and verify that those risks are appropriately managed. And this is, of course, a conversation between both the independent auditor and the business or the project developer. That needs to be a conversation because, again, nothing is 100% secure. We must have a conversation about, are these risks acceptable for our particular purposes within these systems? And then that all gets documented into something that's a final audit report, which then can be used either to publish out to an open source community to show for conversations and to show this due diligence, or it could be used internally to please funders, other stakeholders, to let them know again that there's been due diligence about security, which again, risk management. So I'd like to just mention a little bit about good security practices. Because security audits are just one piece of the puzzle when it comes to doing security in our systems. So some of the other things that you can do for good security practices is to keep an eye on the state of the art when it comes to blockchain technology security. Look at the academic research that is being progressed and published. Also, think about good quality assurance policies and systems within your company or project. Good quality code is less likely to be exploited. And of course, bug bounties are something that are often discussed in this community too, which is offering a reward of money for people to find particular bugs in your software. And these programs can be structured in many different ways. Of course, it's worth mentioning that open sourcing code allows more people to see what is going on in your code, which allows for potentially even further independent verification. And external support of your project and external support of your business will also help you just generally identify what your security threats could be. And generally, we need to incentivize responsible disclosure of any exploits or vulnerabilities that other people find within our system. So it's worth reflecting on what kind of behavior you're incentivizing people in the community, or your end users, or your competitors, or anybody. What kind of behavior are you incentivizing in terms of finding exploits? So security by design is something that's also to talk about. Going earlier into your process, you should think about security from the beginning. This is about prioritizing this and making it an integrated approach as you develop your technologies. Some of this can be done by also sharing, and also not just sharing within your own community, but also sharing within other industries, and with other types of practitioners. Interdisciplinary sharing in general about security is helpful. And to just mention quickly that tech development tools are also helpful, like formal verification and other things that we can do. But I would like to highlight that when it comes to experiences, that it's very important that the blockchain technology community shares failures with each other, because these are what will save us from the big and embarrassing hack stories as the technology is rolled out to more people. So this is just a quick quote that security, in like that it is locking your house or car, it doesn't stop the bad guys, but if it's good enough, they may move on to an easier target. So I wanted to quickly talk about privacy, private data, and blockchains. So the first question is, should the data be public or private? Blockchains allow us to do really great things about accountability and transparency of data. And we need to balance this with people's right to privacy and also the economical benefits of corporations having some privacy too. Off or on-chain data storage is also something to consider. This is about a balance of control and a lot of questions are going to be surrounding how we technically implement these links between the off-chain and on-chain data that we are storing. And I'll quickly mention the General Data Protection Regulation that was discussed earlier today on the panel. This is something that I think is broadly underestimated in terms of impact within the blockchain technology community. And it likely applies to most any online or global technology that we're releasing in the world. It's about protecting personal data rights in light of the big data collection practices that have been done in the past. A couple things to mention about it are the right to be forgotten versus immutability, and also to how we will identify the roles within these new decentralized systems, identify the roles of data controller and data processor. These are things that as a community we should discuss and work with the regulators to try to figure out the best way to handle this and still achieve the goals of the GDPR. So there's also lots of existing research and right now on blockchain privacy solutions that can be implemented. Off-chain storage, as I mentioned, is an opportunity to be able to store particular data that we want to keep private and have it linked back. Hashes and salting are ways, and encryption are also things that we can do, and we can use that to link back onto on-chain. However, these may not be enough in the end. So I do think that things like zero-knowledge proofs and multi-party computation are really the future. Because encryption and hashing sometimes encourages centralization of data stores again, and we also don't know what the results will be with quantum computing. But again, zero-knowledge proofs and multi-party computation are very promising in terms of how these could be implemented for the future. So I encourage everybody to think about security now, research about security techniques, experiment with including new privacy solutions and new security solutions within your technology, participate in interdisciplinary conversations, talk to people in other industries, talk to other people who are solving different problems, and collaborate. Focus on the usability of the security and the usability for adoption of these technologies that we're building. And remember that people use tech. People use technology. Technology doesn't exist in a bubble on its own. It's part of our societies. And vulnerabilities and resulting hacks are generally going to threaten our goals for the adoption. And they can also slow down the adoption of this technology that we find so important. So we need to make security a priority, or our goals will not be met. Thank you.